listeners. This is Olorutoba Kayode. I welcome you all once again to my YouTube channel, Chemistry Apostle. Today, we want to solve questions involving titration, and we are solving 2004 past question. Now, the question on the screen there. Anytime you are solving questions involving titration, first thing you need to bear in mind is chemical equation. The first thing we are going to do is to write a balanced chemical equation for this kind of reaction. A balanced chemical equation for the reaction. And the equation, the acid is hydrochloric acid and the base is potassium hydroxide to give us potassium chloride and water. And if you check the equation very well, you will see that the equation is balanced. The number of potassium we have at the left hand side is equal to the number of potassium we have at the right hand side. All the atoms in the equations are balanced. Okay, then we proceed to our table, formulation of table, whereby we are going to get our titer value. Okay, from the table we have final Bouré reading, initial Bouré reading, and the volume of acid used. The volume of acid used is gotten by initial Bouré reading from the final. Then in the table there, we are going to pick concordance value. The titers that their differences is not more than plus or minus 0.2. Then we are going to pick 2 from the table to get our titer value. Alright, we have gotten our titer value now. The next thing we are going to do is to itemize all the values we were given in the question. We were given mass conc of A, which is mass conc of A, which is 5.0 gram per dm cube. All right, we were given molar mass. We can easily calculate the molar mass of A, which is hydrochloric acid. And how do we calculate molar mass? You add the atomic masses of the element together. Hydrogen, which is atomic mass of hydrogen, is 1, plus atomic mass of chlorine, which is 35.5. When you add the two together, you are going to have 36.5, and that is the molar mass. All right, what else are we given? We can also calculate the molar mass of potassium hydroxide. The atomic mass of potassium is 39. The atomic mass of oxygen is 16, and the atomic mass of hydrogen is 1. When you add everything together there, we should get 56. That's the atomic mass. That's the molar mass of potassium hydroxide. Now let's proceed to the question. In the question asks us to calculate the concentration of A in mole per dm cube. Concentration of A in mole per dm cube. And when you are calculating concentration of A in mole per dm cube, is either you use Savannah, Ca Va, all over Cb Vb is equal to Na over Nb, or we use molarity, which is equal to mass conc over molar mass. In this case now, we do not know our Vb. We do not know our Cb, sorry. We do not know our Cb. Because we do not know our Cb, Savannah, we can't use Savannah. Then we can now use molarity is equal to mass conc over molar mass. The mass conc of A is equal to 5.0 gram per dm cube, then divided by the molar mass, which is 36.5. Then so what we got there now is our molarity of A, which is in mole per dm cube. The next question, concentration of B in mole per dm cube. Concentration of B in mole per dm cube. Now in this case, we can use a molarity of molarity is equal to mass conc of B over molar mass of B. Why? Because the mass we were given in the question, we were not given mass. The mass that we were given in the question was mass of impure. Because of that, we are going to use Savannah now. Okay, so by using Savannah, remember you are going to substitute those values into the formula before you make CB the subject of the formula. So you are going to substitute Ca multiplied by Va, which is our volume of acid used, divided by Cb, which is our concentration of B, the one we want to calculate, multiplied by Vb, which is 25, the volume of our base, is equal to Na over Nb. Na over Nb is the mole ratio of acid to base, and it is 1/1. Okay, we can now make Cb the subject of the formula, then our final answer. Remember, whenever you are calculating molarity, either concentration of A in mole per dm cube or concentration of B in mole per dm cube, it must be in 3 significant figure. 3 significant figure. All right. The next question. Percentage purity of KOH. Now, before we calculate percentage purity, we must firstly know the mass of pure over mass of impure multiplied by 100. So we must firstly get the mass conc of pure B. Now, and in the question we are not given mass conc of pure B, so we are going to calculate the mass conc of pure B, and we can easily get that by using molarity of B is equal to mass conc of B divided by molar mass. So after getting that, we substitute the mass conc that we just calculated into the formula all over the mass of impure that we were given multiplied by 100. Thanks.